Hi guys, I'm here balancing the 40 and I just wanted to make this video to show exactly what I'm going through. Now the first thing that's important to note is that we are missing some stuff from the upper tube assembly, the wrap, focuser, paracore, secondary holder, secondary optic, and an eyepiece. And I'm going to get into all of that later. I want you to see here what I've done to approximate the mirror weight. So to get started, I want you to see I weighed everything. So we got the wrap material on the front end, 5 pounds, 6 ounces. The secondary optic, Mike told me 3.8 pounds, so I'm assuming that means 3 pounds, 12 ounces. The holder itself is 3 pounds, 14 ounces. The Feather Touch with the paracore in it, and I use a 26 Nagler, 3 pounds, 8 ounces, and I even weighed a Telrad at 11 ounces. That comes out to 14 pounds, 51 ounces. 51 ounces converts to 3.2 pounds. 14 plus 3.2, 17.2 pounds is missing on the upper tube. So what you could see here is I put this is a 10-pound plate, a 5-pound plate, and a 2.5-pound plate, which totals 17.5 pounds. I also want you to note that this is on the outside of the spider. Most of the weight is going to be concentrated back here at the center of the focuser. So if anything, this is more weight on the upper tube than is actually going to be there. Also want to take note that the shroud is up all the way. Don't kid yourself, the shroud weighs about 4 pounds. It's going to be spread down the trusses, so we are concentrating more weight up top than is actually going to be there. Now I want you to look at this is the jig I made to simulate the mirror weight. So what you're seeing there is 8 25-pound plates, which is 200 pounds. The backboard is 1/2 inch, and then there's wood to make up the edge mount, and you can also see there's wood behind the weights. That actually weighs 17 pounds. So we have a total of 217 pounds representing the mirror. I want you to also understand that the mirror is 2.6 inches thick. So what I did, the back plate here is a 1/2 inch thick. Then inside of here, I have 3/4 inch wood spacers to bring the weights out. So the face of the weight, the top of the weight that we're seeing here, is actually at 2 1/4 inches from the back of the 1/2 inch wood round. So if anything, if you want to get really technical with this, I have more weight concentrated forward than I do back. So we're probably not representing the full mirror weight. It could be off by a couple pounds. Maybe those weights need to be further to the back by maybe 1/4 inch. I'm not sure. But that would mean that the back is lighter than it's going to be, and the front is heavier than it's going to be. So I'm going to sit here, I'm going to pull this scope down, I'm going to step back, and as you can see, it is going up. So right now, the scope is top light. I was not expecting this. I was expecting to have to add weight. I realized that this scope is approximately 8 inches shorter. With that said, as you guys know, I have an adjustable truss system here. You can see in the bottom trusses there's 2 holes. I am in the furthest out hole, or the longest. The top plate, you can see I have multiple holes up top and 2 in the truss. Again, I'm in the longest out. So the scope right now is being balanced at 139.75 inch focal length, which would be at its extreme. I'm assuming we're going to be a little shorter than that. So anyway, I just want to do this because I want to show you this. This is the math I used when I did the other 40. Radius squared, which would be 20 times 20 times pi. The 2.15 is representing the full thickness of the mirror, taking the sag out of it. So in other words, I'm estimating that the sag, if we if we made the mirror, one thickness all the way across, it's taking out approximately 0.45 inches of material across the whole surface. That's a guess, but I'm sure it's pretty close. And the 0.08 is the density of the material. When you do all of this math, the weight comes up to 216 pounds. That is exactly the weight I used on the other 40, but yet I was 40 pounds light. I'm sorry, I had to add 40 pounds to the back of that scope to make it balance. Really, really confused. Now, I know this scope is approximately 8 or 9 inches shorter than the other 40. However, we made the front end on this 40 deeper and heavier. So we went with 1/8 inch plates for the rings, and I made a crazy heavy focuser board with the hopes that it's going to not add any stress, not add any flexure to the focuser board. So anyway, I'm just trying to say, as far as I'm concerned, the scope is balanced, and let's just make sure we got all our information correct, because I don't want to have to go through in the field on this one what I went through on the other 40, especially after having doing this. All right, guys, talk soon.